All right, with number 12, we want to find the formula for the inverse if possible. So again, I want to refer back to the parent functions. So this is the rational function 1 over x or something over x. You get this graphic. If you were to do horizontal or vertical line test, it will pass both. So this indeed, we can find the inverse of this function. So we will do just that. Again, what I would start out with is writing down the function in terms of y. So y equals, and this is going to be 3 over negative 2x plus 5. Then we're going to interchange x and y, change position. So this is x equals 3 divided by 2y plus 5. Don't forget that negative. And then we're going to multiply to get this off the bottom. We're going to multiply both sides by the negative 2y plus 5. All right, so that's going to cause that to cancel, and then we have negative 2y plus 5 times the x equals 3. Then we're going to divide by x to get that over on the other side. So that's going to leave us with a negative 2y plus 5 equals 3 divided by x. We're going to subtract and move the 5 over. That would give us 3 over x minus 5. And then last we have to divide by the negative 2. So everything over here gets divided by negative 2, so that is the 5 gets divided by negative 2. And then since we already have a fraction, that negative 2 just gets attached to the bottom. So our final answer will be y equals negative 3 over 2x. Negative divided by negative is a positive, and I will just leave it as 5 over 2 since it won't come out to be a whole number. So we'll do negative 3 over 2x, and then plus 5 divided by 2. I wrote that wrong. 5 over 2. Okay, and then 13, our last one, we have two parts. So first we want to find the inverse of the function on the given domain if possible, and then we'll have a part 2. So just inverse on the given domain. So usually the even roots don't give us a inverse, namely because you cannot take the square root of a negative number. However, since x is going to be greater than or equal to 4, when you take the root, like if you do the fourth root, this is always going to be positive. We'll never have a negative. So therefore, we will be able to do the inverse over this domain. So we'll still do the same process. I'm going to write this as y equals x minus 4 to the 4th minus 3. And this is when x is greater than or equal to 4. So what's going to happen when I interchange x and y, this is now going to be y greater than or equal to 4. So my domain is now going to become my new range. I'm going to interchange x and y here. So x equals y minus 4 to the 4th minus 3. I'm going to add 3. Y minus 4 to the 4th. We're going to do the fourth root. So I'm going to get rid of that 4 and that 4. So I have the fourth root of x plus 3 equals y minus 4. And then we're going to add the 4 over. So at the end of the day, we have y equals, and we'll have the 4th root of x plus 3, and then plus 4. So this will be our new inverse function. Our 4th root of x plus 3, then arrow out, plus 4. And then part 2, we want to find the domain of the inverse. So we only want to use numbers that will allow us to have a positive under here. So whenever you have a even root, always be the case when you have an even root, you're going to take whatever's under the radical, and that has to be greater than or equal to 0. It means it has to be positive because you can't take the root. That 4 will not affect what's going on under here. So what values will make this positive? You would have to subtract 3, and that will give us domain x has to be greater than or equal to negative 3. So in interval notation, that would be from negative 3 to positive infinity. Let me see. I couldn't use this one. I asked them for the domain. This seems weird. It won't even let me do a comma. So what are they wanting here? -3. Find the domain of the inverse function. This is our inverse. This would be the domain. They won't let me do this or even put a comma. So I'm not entirely sure of what they're asking for. This function graph, let's look at the graph and see if that helps shed some light. Y equal, clear out what we have. All right, so I'm going to just graph this whole thing. Go to math. Have to do this option number 5 for specific root, and I can put the 4 there, and then actually I want to do this in parentheses. I guess it wouldn't matter. So we have x plus 3, and then arrow out, and then plus 4. Okay, I think I understand what's going on now. Maybe, let's see. I'm thinking maybe because of our range has to be greater than 4, but that shouldn't be a problem because we start above 4. That plus 4 is going to have this shifting up. That's correct, 4th root. All right, let's graph this. Yeah, so if you look at this, if I trace, looks like the domain is going all the way over to -3, and then it disappears. So that starts at -3 and goes to the right. That's your domain. And you can also see the y value. It's decreasing as I get to the end, close to 4. So that y value, this matches up. My range would be y is greater than 4. My domain would be -3 to infinity, but I'm not really sure why it's not taking these inputs. It won't allow me to do this, including the -3, because we can be equal to 0. And then if I do parentheses and I try to input a comma, it says it doesn't like that character. So let me see, express your answer as an inequality. Oh, because I'm trying to do interval form. Sorry. So we want to do x is greater than or equal to, sorry for that delay, -3. Inequality instead of interval form.